Eagle Prime. Command, are you reading?
Affirmative, Eagle Prime. Command is...
Imagine a battlefield where robots rescue wounded soldiers, carry massive loads, scout places humans can't reach, roll silently through water, and even carry weapons. From the powerful Bear robot and strength-boosting Guardian Exo to the Ghost Robotics V60, mysterious GuardBot, tactical T360 M2 MUT, and gigantic Eagle Prime. These machines are changing what modern warfare could look like. But how far can military robots really go? Rescue robots. The first category of robots we'll explore focuses on one of the most critical jobs in any conflict: getting wounded soldiers out of harm's way and getting heavy loads to where they're needed. Bear Robot, developed by VCNA Technologies, is designed primarily to rescue wounded soldiers in active combat zones. A soldier in full gear can weigh well over 100 kilograms, and moving that person out of a firefight manually is dangerous. The Bear robot uses high-powered hydraulic drives to lift and carry loads up to 270 kilograms and relies on 2 pairs of tracks for strong mobility across rough ground and obstacles. Early versions were remotely controlled, with sensors providing audio and visual feedback from the field. The more advanced current generation models take this further, equipped with AI capable of executing high-level commands like navigating to a location or manipulating an object without constant human input. If the robot can't fulfill a command, it asks the operator for help. The latest models also come with infrared night vision, optical cameras, and microphones, letting operators assess a casualty even in total darkness. Next is the Guardian Exo, built by Saros Robotics. This is a robotic exoskeleton worn by a human operator that dramatically amplifies their physical strength. Wearing it, a soldier can carry up to 90 kilograms while it feels like carrying just 5 kilograms. The exoskeleton features 24 degrees of freedom, allowing a natural range of motion and a walking speed of about 1.3 meters per second, close to a normal pace despite the heavy load. Battery life sits around 2 hours, but batteries are designed for quick replacement. The system is simple to wear and learn, making it appealing for widespread battlefield deployment. Rounding out this category is Big Dog from Boston Dynamics. Big Dog is a quadruped robot moving on 4 legs like an animal, with dynamic stabilization that lets it maintain balance across rugged, uneven terrain where wheeled vehicles would struggle. Its exact payload isn't specified, but it was clearly designed for versatile equipment transport. To achieve this stability, Big Dog is loaded with around 50 sensors measuring motion, actuator forces, and engine parameters, plus multiple cameras for real-time environmental perception and autonomous locomotion control. Recon robots. Moving from rescue to reconnaissance, the next group of robots is built for adaptability. Machines meant to scout ahead, gather intelligence, and operate across a wide range of terrains without putting soldiers at direct risk. The Ghost Robotics V60 is a mid-sized, 4-legged robot designed for both defense and enterprise applications. It weighs 51 kilograms and can carry a payload of up to 10 kilograms, enough for sensors, communication equipment, or small supplies. It can be assembled or disassembled within 15 minutes, giving units flexibility for rapid deployment. It can move at speeds up to 3 meters per second, and on a single charge, it runs for about 3 hours or covers roughly 10 kilometers. Operators control it using a gaming-style controller, which keeps the learning curve low for soldiers already familiar with modern electronics. For situational awareness, it provides 360-degree vision through front, rear, and side-mounted cameras. And because its legs and arms are modular and interchangeable, the platform can be reconfigured for different missions without needing an entirely new robot. Alongside the V60, the U.S. Army has also collaborated on a range of MX Phoenix hexapod robot, purpose-built for some of the most difficult environments imaginable: dense urban areas, mountainous terrain, and cave systems. This includes spider-like autonomous reconnaissance scouts, small enough to move through tight spaces where larger robots simply can't go. These mini robots are equipped with autonomous navigation sensors, obstacle traversal capabilities, and both thermal and standard cameras. Their core purpose is straightforward but vital, safely gathering intelligence in areas that are either lethal or completely inaccessible to human soldiers, reducing the number of people who have to physically enter high-risk zones just to understand what's happening inside them. Amphibious robots. The third category covers systems that don't just operate on land. They're built to move seamlessly between land and water while performing specialized detection and surveillance work. The standout system here is GuardBot, a U.S. Marine Corps project and genuinely one of the more unusual designs in modern military robotics. It's a spherical robot, and its shape isn't just for show. It enables a unique method of movement. GuardBot is used for surveillance and for detecting improvised explosive devices, commonly known as IEDs. It's capable of operating on both water and land, though at very different speeds, roughly 6.5 kilometers per hour in water and up to 35 kilometers per hour on land. It can also handle inclines of up to 30 degrees, which is a genuinely meaningful capability for navigating natural terrain or defensive positions. What makes GuardBot especially interesting is how it moves. There are no external wheels, legs, or tracks. This sealed design also protects the internal components from water, dust, and debris very effectively. Power comes from Eagle Packer batteries, giving it up to 18 hours of continuous operation, a solid endurance window for extended surveillance missions. And critically, it moves silently, making it well suited for covert operations where noise could compromise the mission. Its onboard equipment includes observation cameras, sensors, and laser identification technology for detecting chemical substances. Depending on the specific mission, it can serve as a transport vehicle for bombs or function purely as an explosive detector. UGVs and the SKED stretcher. Hello everyone, and welcome back. When the U.S. Army tests unmanned ground vehicles, one mission stands out above all others: getting a wounded soldier off the battlefield alive. During X-Tech Edge ground strike, held at Grafenwohr training area in Bavaria from March 2nd to 13th, 2026, soldiers from the 2nd Cavalry Regiment put robotic platforms through real tactical tasks. Alongside reconnaissance, route clearance, and resupply, one mission kept surfacing as critical: casualty evacuation. And one simple, proven piece of gear kept appearing in these robotic payload setups: the SKED stretcher. The SKED has been a battlefield staple for decades. It's lightweight, rolls up for easy storage, and can be dragged across almost any terrain without folding or tearing. On its own, it already saves lives. Paired with an unmanned ground vehicle, it becomes something more: a way to pull an injured soldier out of a danger zone without sending a second soldier into the same fire. During the trials, crews strapped SKED stretchers onto small UGV platforms and practiced remote extraction drills across rough, uneven ground. This is what modern battlefield testing really looks like. Not flashy demonstrations, but soldiers asking hard questions. From scouting drones to robotic pack mules, the pattern is the same: machines moving ahead of humans, so fewer humans have to move into danger first. Combat UGVs. The final category brings us to the heaviest hitters: unmanned ground vehicles built specifically for combat support, tactical mobility, and in some cases, direct offensive capability. The FLER Cobra robotic system, made by Endeavor Robotics, is a multifunctional tracked platform weighing about 166 kilograms. It has a top speed of roughly 8 miles per hour, or about 13 kilometers per hour, and it can run for up to 10 hours on a single charge. The Cobra is equipped with multiple high-definition cameras and a manipulator arm capable of handling payloads up to 60 kilograms, giving it real dexterity in the field. Its remote control system includes advanced cybersecurity and interference protection, which matters given how sensitive its missions can be. Those missions include explosive detection and disposal, persistent observation of an area, and vehicle checkpoint inspections. Perhaps most notably, the Cobra can detect and identify chemical, biological, radiological, and nuclear materials, commonly grouped under the acronym CBRN, entirely from a safe remote distance. Next is the T360 M2 MUT, short for Multi-Utility Tactical Vehicle. This is a hybrid drive tactical robot available in both wheeled and tracked versions, and it has been formally adopted by the United States Marine Corps after passing successful testing. Its payload capacity is substantial at 433 kilograms, and it's built for endurance, with autonomous operation lasting up to 72 hours and a range covering more than 100 kilometers without human intervention. What really sets the T360 M2 MUT apart is its modularity when it comes to weapons. It can be configured with several types of machine guns, or alternatively fitted with a 60mm mortar. Finally, there's Eagle Prime from Megabots, and this one is on an entirely different scale from everything else discussed so far. It's a giant 12-ton combat robot standing 5 meters tall, powered by a 6.2-liter V8 gasoline engine producing 430 horsepower. It's equipped with a cannon and a claw, and it requires 2 operators working together on its tracked platform. Eagle Prime began as an entertainment project rather than a military one, built for exhibition combat between giant robots, with a project cost of around $2.3 million. Still, its scale and engineering have drawn attention to potential future military applications. Closing thoughts. Looking across all these systems, a few clear patterns emerge. American military robotics increasingly emphasize multifunctionality, autonomy, and modular design, with AI handling more high-level commands and reducing the need for constant operator input. Payload and endurance remain key differentiators, from lightweight scouts to massive tactical vehicles. Amphibious and all-terrain capabilities, as seen in GuardBot, add real tactical flexibility while interfaces grow more intuitive, from gaming-style controllers to exoskeletons needing minimal training. Together, these systems reflect a rapid shift in how mechanical innovation, AI, and sensors are reshaping military operations, improving soldier safety and opening new tactical possibilities worldwide.